Okay, ladies and gentlemen, here we go. Problem number 1 has to do with limits. The easiest way to deal with limits, especially when you have a picture, is to put up the fence. Okay, so it says the limit of 2. So I draw a line at 2. Negative is less than. Less than is the left-hand side. On the left-hand side, the graph touches at what height? 3. The right-hand side, the function touches the purple line at 1. So at 2, does the function exist? No. Does not exist because they don't meet up. They disagree. Yes? Okay. Next, they want me to look at the function of 0. So I'm going to put a line at 0. Sorry, let me switch colors. It didn't switch. Okay, so I'm going to put a line at 0. Less than, on the less than side, it touches at a height of? 2. At the right-hand side, it touches at? So the limit is 2. Please ask any questions if you have questions about limits. We're all good? Okay. No, what is your question? Can I explain C? Does my right and left hand agree? Are they the same value? No, therefore the limit cannot exist. Okay? Then that becomes the limit. Good? Okay. Next picture. They still want me to look at 2. So when I look at 2, what's the height of the left-hand side?
4.
What?
1.
Oh, I put the line at the wrong spot. Sorry. Woo, sorry. It's on the right-hand side, it's 4. Left-hand side, it's
4.
Therefore, the limit is 4. This dot is not a function. It is a point. You're looking at the function. Okay, now looking at 0. There's the 0 line. The right hand touches at?
1.
Left hand?
1.
Therefore, the limit is 1. This dot here is only good for function notation. If I asked you f of 2, you would then say 1. It does not help me with the limit. The limit is looking at the functions of, looking at the graphs. Okay? Okay?
Is the test Monday or Tuesday?
Tuesday. I would not do that to you on a Monday. Yes? What are you talking about, the limits at 0? Which, are you talking about D, E, or F? Question A? 2A. I know, but we have to look at this. It's talking about a wall at 2. You good? Okay. All right, next question. Okay. Now, at this time, I have taught you how to do it paper and pencil style. I will do it that way. You may also, calculators allowed on the test, you bring your graphing calculator, you can type it in. If I have a picture, how do I know if it's even? Symmetrical to what? Y-axis. Okay, how do I know if it's odd?
Symmetrical over y equals x.
Symmetrical through the origin, okay? It has to go through the origin to be odd, and neither is, it doesn't match either of those. So this one here, I'm going to rewrite it. So it is the square root of x to the 5th, yes? Yeah? Wrong. Thank you. It's power over root. Thank you for those of you paying attention. Power over root. Okay?
Wait, can you repeat how we know it's odd?
Odd if it's reflected over the origin and it goes through, it has to go through the origin. So its center needs to be in the origin and then it has to reflect over the diagonal. Either quadrant 1 to quadrant 3 or quadrant 2 to quadrant 4. Okay. Now, here we go. I can pick any number I want. for x, right? And no matter what I pick, if I pick negative 2 or positive 2, I'm going to get what? What am I going to get? I'm going to get the same answer. Why am I going to get the same answer if I pick negative 2 or positive 2? Because this power here is even. Okay? All right, so what do you mean that's confusing? Okay, so I'm going to go with negative 3, negative 2, negative 1, 0, 1, 1, 2, and 3, right? Okay, so if I plug in negative 3, that's 9, right? So this is going to be the fifth root of 9. But this is also going to be the fifth root of 9. Okay? It doesn't? What's negative 3 squared?
Oh, never mind. Okay.
What's negative 3 squared? 9. What's 3 squared? 9. Okay? All right? It's going to be some sort of teeny number, okay? Let's go with an easier number. Let's go with negative 1, right? What's negative 1 squared? 1. What's the fifth root of 1? 1. Oh, guess who else is 1? This one. What's the fifth root of 0? 0. So I'm going to have some sort of graph that looks like this. Yeah? Okay? Something like that. I think I did that wrong. Sorry. That's wrong. Hold on. That's wrong. I'm sorry. So if I do 2, the fifth root of 9, all right? The fifth root of 9, okay? I think it is something like that. Yeah. Or is that 5 halves? Check. Is it 2/5 or that's 5 halves? Yeah. Yeah. I'm confused. Hold on. Let me. Okay. Yes, if you bring one. Okay, so what type of symmetry would you say? It's even. Why? It can fold over that y-axis, so this one is even. Okay? Let's look at the next one. You can just determine that if negative 3 and positive 3 give you the same answer, that's a mirror image over y. That is always a given. Cool? All right. So, this is even. I had to clear the screen so I can do the next one, okay? I am showing you the long way. Because you need to know how to do it without a calculator, because when you move on to calculus, it's going to be without a calculator. So this becomes 1 over the square root of x cubed. Okay? All right. Somebody brought out a very good point. The easiest one to test for, right? The easiest one to test for is even. Because if I take a negative and a positive of the same exact number and get the same output, it's going to be even. Hence the reason we take a function, we replace x with negative x. Because we reflect it over the y-axis. How do you reflect x over the y-axis? Negative x. That's why that test works. Okay? All right, so if let's do that test. If I replace x with negative x, can I answer this problem? If I replace x with negative x, can I answer this problem?
No.
Why not? I can't root a negative number. Therefore, in order for me to do this problem, all my x's have to be what? Positive. If they're all on the positive side and never on the negative, Can they reflect over the y-axis? No. Can they reflect over the origin? No, not in that case. So that one's going to be neither. It has no reflection, no symmetry. I'll make a quick graph for you. Let's go with -2, -1, 0, 1, and 2, okay? -2 cubed is -8. Can I take the square root of -8? No. So does not exist. -1 cubed is -1. Can I take the square root of -1? Does not exist. All right, 0 cubed is 0. Can I take the square root of 0? Can I take the square root of 0? Can I take the square root of 0? Yes, and I get 0. 0 squared is 0. Now, that leaves me with 1 divided by 0. Is that going to work? No, so it does not exist. Okay? So now I realize that it has to be any number bigger than 0 and positive. Well, in order for it to be odd, it needs to touch the origin. If I can't be 0, can I touch the origin? No. In order for it to be an even function, I have to have positive and negative give me the same value. I can't have negative values. Therefore, this function is neither. Good?
Wait, what if the function is like this? It's not just an origin. Like this one.
That is a rare case. That one would be, I have to double check.
Okay.
All right. Now, this one, I'm going to just do the simple tests, okay? I tell you, whenever it has a fraction power, do the table test, okay? Fraction power, table test, yes? If it's a traditional, I saw this in Algebra 1, we're going to do it the traditional way. So -x cubed plus -x, yes? What did I do? I replaced every x with -x because I'm trying to see what happens when I reflect over the y-axis. When I reflect over the y-axis, I get -x cubed minus x. How does that compare to my original equation? Everything's reversed. Therefore, it is odd. Okay. Yes, that's why I'm taping it. Plus, I have my even and odd video if you need to go back over that. Okay? If I had plugged it in and everyone stayed the same, it would be even, Steven. Everyone opposite, odd. If I'm a mix, I'm neither. All right, this last one is 1 over x to the 4th power. What's going to happen if I plug in -2 and +2? It's going to be the same exact answer. So it's even. That brings me to another test, okay? You guys struggle, and by you guys I mean all students. Every year it's a struggle, even odd. Okay? No, it wouldn't work. It doesn't always work. We'll come back. I was going to make it easier for it, but it only works for an even, to test for even. It doesn't work for odd. So we're going to skip that because I don't want to confuse your brains. Okay? All right? Moving on. Okay. Where is the one point of transition? Where's the one point of transition? -3. -3, okay? All right. So this first question asked me about, -3, okay? So the value of x at -3, so we're going to test it in both equations, okay? In both equations. Because that is the transition spot. So we have 2 to the -3, which is 1 over 2 to the 3, which is 1 over 8. And this is talking about looking at the limits and the types of discontinuity, okay? What is your question?
I did 1 over 2 to the
What does the original equation say?
2 to the negative
2 to the negative 3. What do we do when we have a negative exponent?
3.
We do the reciprocal of the base. So we end up with 1 over 2 to the third. 2 to the third is 8. So my answer is 1 over 8. Everyone good with that? Yes. I've only started. I'm not done with the problem yet. Because it's the transition number, I have to do it in both. You need to, we're looking at the limit. So ignore that one of the symbols has equal to. Okay? Yes.
And you would end up with 1 over 8.
Yes. For the top. Now I have to look at the bottom equation, which is 3 over negative 3, which is negative 1. Do my responses match? No. So it is what type of discontinuity? It is a jump. How do I know that it's a jump? Limits don't match. My left hand and my right hand, okay? Good. Now, is that case going to apply for this one? 0. No. Okay? 0 is not a transition number. How do I know 0 is not a transition number?
It's not in the limit.
It's not in the restriction, okay? So there's only one equation that I can plug 0 in. Yes? And what would it be? The top one. Okay, so that's going to be 2 to the 0, which is 1. Okay? That's wrong. Who told me the top one? What does the top say? Less than negative 3. Is 0 less than negative 3? No. Oh my goodness, I can't trust you guys anymore. So the problem is 3 divided by 0. Uh-oh. Can't do it, which means I have a what? No. If I break one of the rules, I have a what? It's an infinite discontinuity. Can't divide by 0. It's an infinite discontinuity. Because I have a what? Okay, which gives me a what? What did we study all week? That was last week. What did we study all week?
What did we study?
Thank you, asymptote. I have an asymptote, which means something's heading towards infinity. That's why it's infinite discontinuity. You know, you guys just told me the infinite. You didn't tell me about the asymptote. All right. 2. Which can 2 go into?
The second one.
It can go in the second one. It can only go into 1, therefore it's going to be what? Continuous. Because when I plug 2 into the only equation that works, it does give me an answer. And there's only one possible answer. There's no conflict, so we're good to go. Yes?
Yeah.
Okay, so we're going to move to the next problem, which studies the same exact thing, except for it has 3 equations. What are my points of transition? 2 and 5. Those are my points of transition. So the first question right off the bat asks me about 2. So I have to look at the left and the right hand of 2. Okay? So when I plug it in, let me label this. A, B, C. Which 2 equations am I going to plug it into?
X plus 4, negative X.
So A and B, yes? Okay, so I'm going to do 2 plus 4, which is 6. If you can't do that, I'm going to cry. Then I'm going to do negative 1 times 2 squared plus 8 times 2 minus 8, which is negative 4, plus 16 minus 8, which equals 4. So I got a 6 and I got a 4. What do I have? is a jump because my limits don't match. Limits don't match. All right. Next one. 5. Is that a transition number?
Yes.
Yes. Which two equations am I going to use?
Negative x to the second plus 8.
Second and the third, B and C. Okay, so I have negative 1 times 5 squared plus 8 times 5 minus 8. Okay, which is negative 25 plus 40 minus 8, which ends up being 7. Okay? When I plug it into the other one, yeah,
Why do you put in 1?
it's a negative x. It's negative, this really means negative 1 times x squared, and I write it there because a lot of students just take their x and they flip the sign and then square it, which is incorrect. Only the x is squared. So you have to square your value and then multiply it by the negative. Okay? That's why I write it out that way so people don't mess up the sign. And then we have 5 plus 2, which is 7. So it matches. So what type of discontinuity is that? No, it's discontinuity.
What? They match.
It is a hole. What's the correct name for hole? Removable.
Oh yeah. Wait. Why is it
Because the limits match. Because there was only how many functions? One function.
Yeah. What do you mean there's one?
Because there's only 2 functions.
There was 2.
The value of 2. I have a value of 2. Which equation? Can I plug it into both equations?
Oh.
No. There's only one equation. I can plug it in. Therefore, it is continuous. So, the value of 3. How many equations can I plug that into? 1. Therefore, it is continuous. Okay, let's read this. Values less than or equal to 2. Is that true for 3? No. Values between 2 and 5. Yes. Values bigger than 5? No. So there's only one category it fits in. So it would fit in only one equation. So it is now technically I jumped right into continuous. You really have to make sure. Time out. Shh. If it only works for one function, it's either continuous or it's infinite. How do I know if it's infinite? If it breaks one of the two rules, either a negative of a square root or divide by 0. I just jumped right to continuous because I was lazy. Because we're not square rooting and there's no division, so obviously it's going to what? Work. Cool?
Yeah.
All right. Moving on. All right. Now, this is what we worked on last week. Here's our friendly word. Awesome dope. Yes? So, am I dealing with a Betsy, Bob's, or Bo2? I got a Betsy. A Betsy because 2 matches 2. Lead coefficient of 1, lead coefficient of 1. 1 divided by 1 is? 1. So my horizontal asymptote is? Y equals 1. Don't leave that off. I know I'm lazy and leave it off sometimes. Y equals 1. Yes?
Wait. Can you say that again? I thought we circled everything because I don't.
Okay, first thing I do is compare powers. They are the same. So bottom equals top. Betsy, C stands for coefficient. Coefficient of the top is 1, coefficient of the bottom is 1. 1 divided by 1 is 1. What is the next action I should take?
You divide.
Factor. Thank you, Nathan. I'm going to factor. So I have x plus 4, x plus 3, and on the bottom I have x minus 3, x plus 3. What do you notice?
X plus 3 is 5.
It matches, therefore it's a hole. Where is the hole? X equals negative 3 because I have to solve for 0. Thank you. How did I factor? Shh. The bottom? Perfect minus perfect. And I'm glad you asked. If you forgot how to factor, the second from the top video on Google Classroom, where it says key concepts so far, that's the video you should be watching. IOKSUD. Okay, now, I don't care about the rest of the numerator. It doesn't give me any extra information, but what does this guy here give me? Vertical asymptote at x equals 3.
Wait, don't stop. Don't wait.
The hole is miscellaneous.
Yes.
So the hole is always
yeah,
the
that makes
opposite.
sense.
Like since it was x plus 2, it'll be
There's a hole at x plus 3, but you need to solve for x to tell me where the hole is. Now, technically, you are supposed to give me the full address of the hole. And I didn't go over that. So let me go over that right now. Okay, here's how you find the full address of the hole. We're going to cancel out the hole. What's left? X plus 4? X minus 3. I'm going to use negative 3. What's negative 3 plus 4? What's negative 3 minus 3? So, comma, so it would be the order pair, negative 1, 6. Okay, let me repeat it. To give the full address of the hole, you're going to cancel out the hole. You're going to take the x value of the hole and sub it back in. So negative 3 plus 4 is 1. Negative 3 plus negative 3 is negative 6. So negative 1, 6. Negative 3 plus 4, negative 3 minus 3. 1 over negative 6. Negative 1, 6. Okay? That is the full address of the hole. Yes?
about the second one. The hole in the second one.
Okay, we'll get there. All right? Next. Is it a Betsy, Bob's, or Bo2? Betsy. 1, 1, so HA is y equals 1. When I factor the top, it's x plus 3, x minus 2. Yes?
Yeah.
Then I have x plus 3,
X plus 3.
x plus 3. I have a hole. Where?
X plus 3.
X equals negative 3 is a hole. Now, this is the same exact thing. So it's also going to give me a hole, right? It's repetitive, so it doesn't matter. It's repetitive, so it doesn't matter. So the vertical asymptote would be 9. Okay, but we got to finish my hole, right? So I'm going to do negative 3 minus 2. The bottom doesn't matter anymore. It is negative 5. Because they're the same exact.
What about the first
It doesn't matter. I was talking about two different things about when they matter and they don't matter. Okay. All right. Over here, the x plus 3 was a hole. The x minus 3 is not a hole, so it's still there. Anything left in the denominator, that is not a hole is a vertical asymptote. Can I have more than one vertical asymptote? Yes. You can have more than one. Okay. Good? Now, technically for a hole, you have to give an ordered pair. So after I get rid of everything that's considered a hole, so that's all my x plus 3's, whatever's left in the original equation, I replace with the x of the hole. What was the x of the hole? Negative 3. Negative 3 minus 2 is negative 5. That's how I got the full ordered pair. Good? Yes. Because it says x minus 2. I plug it into what's ever left in the equation. Good? Yes, that's only for a hole that you have to plug back in. Because a hole, you have to, we got to fill the hole by giving a full address.
I get it, but like why? I still don't know why the verb I differentiate like where first one was X plus three, second one would be. Can you explain the first one?
Okay, so we established that x plus 3 was a whole. What does this say? X plus 3 is a whole. If it's a whole, it cannot be a vertical asymptote. Okay. Yes.
Will this give you the full address on the test?
Yes. It's just plugging in. Just subbing back in. Okay. Now, let me. Right. After you draw a line through everything that's a whole, you plug the x value into whenever's left. So, for example, this was left and this was left. So I plugged my whole in and got negative 1 over 6. Good? Yes.
You don't put it as an order pair when you get it.
You don't get full credit. No. You have to have a full address for a whole. Okay. Moving on. Now, the numerator gives you the x-intercepts. The numerator gives you the x-intercepts. We did not practice that yet. We will practice that Monday. What was the question back here?
I asked why is it on the first one, fraction on the second?
Okay, so this is a whole and it canceled out, right? So this is everything that's left. Everything that's left, I have to take my whole value of negative 3 and plug it in. Negative 3 plus 4, 1. Negative 3 minus 3, it just so happened that it was a fraction. Okay? Now, hold on. Over here, I drew a line through everything that was part of the whole. All that's left is x minus 2. There's nothing left in the denominator now. So when I sub it back in, that's why there was less. Okay? Yes. The horizontal asymptote is 1 for both of these. Because of Betsy. Okay, moving on. Next question. All right. So, I will come back to this only because we're running short on time. And this is one of our last ones. So, synthetic division. So, I'm going to do 1. And then I'm going to do negative 3, 0, 2. What is the 0 of the denominator? Okay, drop it like it's hot. Negative 3 times 1 is negative 3. Add it, negative 3. So y equals negative 3x minus 3. Okay? The next one, what goes on the outside? Negative 2. 5, negative 3, and 1. Drop it like it's hot. 5 times negative 2 is 10. Negative 3 plus negative 10 is negative 13. So y equals 5x minus 13. Good? Okay. All right. I'm trying to get it so it's all done. All right. So this is A and B. So I'm going to factor this. X minus 1. It is a GCF factoring. If you don't remember factoring, you need to rewatch that video. A, B. So A times x minus 1 plus bx equals negative 5x plus 4. What's the first 0 I plug in? What's the first 0? 1. I'll see you on Monday. Okay, so I'm going to plug in 1 here, here, and here. This goes bye-bye. I have 1b equals negative 1. Therefore, b equals negative 1. I come back, and I'm going to replace it with my other whole, which is 0. So 0, 0, 0. So negative 1a equals 4. A equals negative 4. Okay? Okay, so same thing. I'm going to factor the denominator. So two numbers that multiply to 20 and add up to 9 are x plus 4, x plus 5. So then I get a times x plus 5 plus b times x plus 4 equals 3x plus 10. I'm going to replace x with my first zero, which happens to be negative 5. I get negative 1b equals negative 5, therefore b equals 5. And then for the other one, I'm going to use negative 4. So I get negative 1a equals negative 2, a equals positive 2, problem done. Please go back and watch the video on function composition really quick, because I did not go in order because of the bell, sorry. So this simply means you have to do f of g of x and g of f of x. So I'm going to take this and plug it in here, and then later I'm going to take this and plug it in there. Good luck.